So let's actually take a look and see what these equations mean. X bar, remember, is the I guess the centroid location for the x direction. And what does this mean? So here, this means you take the x bars of each individual shape. The I is an index because you might have more than one shape. So you take each of those and you multiply it by the area of each individual shape, and you add them all together. And I'll show you what that means in a second. And we'll do more examples probably in class before we actually get started on our own. But here it means for each individual shape you might have a couple x bars because you might have a couple different shapes. So you'll find the centroid location on the x axis for each shape. You'll multiply it by the area of each shape, and then you'll add all those together for each shape. Then what you'll do is you'll divide it by the area of all of the shapes. So this area is for the x's, and then this area is for all of the shapes. Well, I guess it's the same thing actually, because each of them have an x direction, each of them have a y direction, each of them have a z direction. So that's actually the same. So this quantity and this quantity will be the same. So let's take a look at an example. This will be using, actually it's called the subtractive method, where we take away some area. We could divide it up into a triangle and 3 squares, and then we could do it like that, but it's easier in this instance if we just make it into one giant square and then also a triangle. So this would be shape 1, this will be shape 2. Shape 2 in this instance will have a negative area because we're taking it away. That's why it's called the subtractive method. So that's what we're going to do. The x bar, the y bar, that's going to be the distance away, the distance that the centroid is away from the reference axis. So I'm going to go ahead and choose a reference axis. You can actually choose it to be wherever you want, but it makes the most sense if you just choose the reference axis to be like the x and y axis. Okay, so what are our two shapes? So let me write the instructions here. Okay, find the centroid. So we have all these dimensions, and I need to find the centroid. Well, to find the x bar for the total thing, I have to do it individually for the shapes. Shape 1, I said, was going to be this large square, and shape 2 is going to be the non-existent triangle, the empty triangle. So for shape 1, it's just a 6 by 6 inch square. So what do I need? I need the x bar for a square, and that's just halfway between halfway between the sides. So there's that, and then the area of the square, I'll need that. And it's only one shape, so I don't have to add anything just yet. I'll do it for when I do both shapes. So shape 1, the square, the x bar for the square, since the whole thing is 6 inches, I'm looking at this whole entire square. Since the whole thing is 6 inches, that means x bar is 3 inches. So that's easy enough. And then same for y bar. That's going to also be 3 inches because it's just half of that distance. Now I don't have a z bar, so that's pretty much it for that. And then the area of shape 1, so I'll say the area of 1. Well, the area of a square, that's just length times the width, or base times the height. And we're considering the whole entire thing, so that would be 6 times 6, that's 36 inches squared. So it looks like I have all of the information that I need for my x's and for my y's. So there's that. But I need it for all of the shapes. That index means it's going to be changing, so I need to do it for all of my shapes. So what's my second shape? My second shape, shape 2, is that triangle. So I'll do it over here. Now this triangle, I'll redraw it, and this triangle is an isosceles triangle with 3 inches, 3 inches. And it's a right triangle. It's a right triangle. So the centroid location, the x bar, that is going to be, remember, for right triangles, it's going to be 1/3 of this distance. So that's going to be 1/3 times 3 inches. So that's just 1 inch. And it's 1 inch from the right angle. So it's actually like that. That's x bar right there. So that's 1 inch. And then same with y bar, same exact principle. So that means y bar is there. So the centroid of this little guy would be right there. So there's the centroid of that. And then here's the centroid here would be like, let's do it in green, somewhere there, right? Because that's in the middle of both of those. Now I'm eventually going to have to adjust these because I'm combining them with the centroid of this whole entire shape and the centroid of this shape. So that's what I'll end up having to do. But that shows in my equations. Oh, I need to get the area of the triangle. So the area of the triangle, that's 1/2 times base times height. Base times height. But I know that the base, if I flipped it around, the base would be 3. The height would be also 3. So 1/2 times base times height. That's the same as, 1/2 times 3 inches times 3 inches, which would be 9/2, 9 inches over 2 inches squared, which is 4.5 inches squared.